All right, sinusoidal functions. So we're going to start modeling quote unquote real life situations. Sort of. All right. Minimum depths of water in a harbor, T hours after midnight, can be approximated by the function 12 plus 5 cos 0.5 T, where T is between 0 and 24. Why is T between 0 and 24? Because there's 24 hours in a day, right? Okay. What are the maximum and minimum depths of the water? How do you find max and min from an equation? We did this right at the end on Friday. A and D. So it was A plus D and negative A plus D. What's my A value? 5, yes. Plus 12, which is 17. And negative A, so negative 5 plus 12, which is 7. So we have a maximum depth of 17 and a minimum of 7. Above the average. Okay. What's the period of this function? How do you find period? 0. That's your B value. So it's not going to be 360. It has to be in radians because there's no degrees in there. All right. And we're approximating heights and stuff. So all of these problems are in rads. Okay. So 2 pi over B, 2 pi over 0.5 is 4 pi. Okay. What is the depth of water at 2 a.m.? What am I going to do? I'm going to put 2 in for T. And you're all going to do that right now and tell me what the answer is. What mode must your calculator be in?
Oh, they just rearranged.
Yeah. They're just messing with you. AKA, I'm messing with you.
Wait, so what is the 12? Isn't the 12 D?
It's exactly what it is.
So can I just add it to the end to make myself happier?
Make yourself happier.
Yeah.
Yes, you can add it to the end to make yourself happier. What are you confused about? You would, if you want to use degrees on your calculator, you'd have to convert 1 rad to degrees, and then you can do it. Right? What did we get? 14.7 meters.
Whoa, why did you get that? What? Oh, buddy, I got it. You didn't do 2 a.m. Why do we have to compare
Are we okay? All right. Did everybody get 14.7? This is important. I will ask you to do this on a test or something similar to this on a test. All right. Going once, going twice.
So the reason we have to do this in rad is because our 0.5
Is yeah, and we're talking about like rads don't have units, right? Degrees have units, like your degrees, and we're not measuring angles. Technically, I mean, I guess you could say we are, but we're modeling a tide going in and out, right? So yeah. Yeah. But you could, if you really wanted to, like 2 times a half is 1. if you converted that to degrees, you could put that in your calculator and you'd get the same answer. Yeah.
Would you not divide this by 2?
Why?
D times 2?
No, that's d of 2. Sorry. It's like a function, right? Time is 2. The depth of the water at 2 a.m. is blah. All right. Okay, here's the 8-point question, peoples. Or a version of this. So, when we were doing the provincial exam, which was a long time ago, this was always a question on the provincial exam, so everybody had to know how to do it, and it's a really good question, so we're going to do it. Higher mental process, look at this symbol. No calculator. If I put that on a test, your heads would explode, wouldn't they?
Yeah.
Simply, even if it was like addition. And it's not that you don't know how to do it. I think everybody's just so used to having a calculator. I know. I've seen people do 5 divided by 1. Don't laugh. I know. All right. Here we go. Did you say 5 divided by 1 is what? Is 1? Is that what he said? Okay. This is all being recorded too, so you guys are going down in infamy here. All right. A wheel with a radius of 20 centimeters has its center 30 centimeters above the ground. It rotates once every 15 seconds. Determine an equation for the height h above the ground of a point on the wheel at time t if this point has a maximum height at t is equal to 2 seconds. Let's cross out that last bit because I actually don't want that in there. So determine the height of the equation at time t. This is what we don't want. Is that even on yours, that part? Yeah. Okay. Okay. Basically, I want the equation that describes a point on the wheel going around. So, where should we start? That is the best thing. So we're going to draw a Ferris wheel. I'm going to draw a circle and pretend that that is a Ferris wheel. Okay? A circle. There's my circle. Now, you have to read the question carefully. It says that its center is, it has a radius of 20 centimeters, and its center is 30 centimeters above the ground. You just rephrased what this says. Yes. The bottom of the wheel. Well, it's a Ferris wheel. You don't put, if you put it on the ground, it would roll away. Okay, it's a wheel. Sorry. It's a floating wheel. The radius is 20, and then this is 10. And I clearly drew it to scale. All right, does that make sense to everybody? All right. Now, no, don't do it. Okay, what's its rotation? 15 seconds. It takes 15 seconds to go all the way around. How long does it take to go halfway around? 7.5. Look at this. We didn't even use calculators. So this is 7.5 seconds. How long does it take to go a quarter of the way? 3.75. How long would it take to go 3/4?
11.25.
Everybody understand how I'm doing that? I just do. That doesn't matter. You can assume it's your choice. Your choice. Okay. So it doesn't matter. It doesn't matter. It's irrelevant. Okay, we're gonna draw. Sorry? I'm not asking which way it's rotating. I'm asking what's the equation of this. Okay. You can draw it any way you want. I'll let you figure that out. Okay, we're gonna do a height versus time graph. Not oh no, it's gonna be fine. H of t or H. Let's call it H. Sorry. Okay. At 0 seconds, this is time in seconds. At 0 seconds, how high? If a point, let's say a fly, is sitting on the wheel right here. At 0 seconds before we start the wheel, how high is it? At 3.75 seconds, how high is it? It's 30, right? Because you're right here. Okay, so you're 30 centimeters. How high are you at 7.5? 50. How high are you at 11.25? 30 again. And then how high are you at 15 seconds? You're at 10. You've come all the way around, right? 30.05, same thing. So the graph looks like this. There's your graph. We only do the graph for the visual, right? It helps, I think, with the visual. Okay, now you've got a graph. You have to give me sine, cosine. I keep wanting to say tan, but you only have to give me sine or cosine. A is positive or negative. You have 4 possible answers. It's just like the question we did right at the beginning of class today. So what's the first thing we should calculate? A, okay. Whoa. So my A value is max minus min over 2. That correct? Yep.
When we're writing like the equation, we don't need to put like or when we're labeling our A value, do you want us to name units with it? Like
Okay, we should do, what's the next easiest thing? I'd say D. It's the same number except you're adding them. But it's your choice. I'm going to do D. All right. I'll give you a mark for the graph and or the Ferris wheel thingy. You get a mark for each of these. You got 3 marks. Congratulations. How can you get another one? Fine. Well, C is probably the most difficult, but we could find B value, right? Because we know the period. What's the period? What's the period? 15. It's how long it takes to go all the way around, right? So the period is 15. A, you have to do it in rads. So it's equal to 2 pi over B. So what's my B value? 2 pi over 15.
why do you have to do it?
Because there's no degrees, there's no angles in here.
So could we get the exact value by so long as our calculator's in rad 2 times that so long as it's in rad.
Oh, but putting it in your yeah. Okay. We got A, D, and B. Now we got to do C. C is dependent on which function you want to do. I'm gonna do all of them, but if you just pick one and go with it, that's fine. All right. So if we're doing sine graph, and we're doing A is greater than 0, the equation is h of t is equal to, what's our a value? 20 sine, b value is 2 pi over 15, and that x t. T what? What am I looking for if you're doing a sine graph that has a positive a value? Rising midpoint, right? Which is going to be 3.75. Because that is your mid. I don't care. You can use the decimal. So there's your midpoint. The midline is your d value. The rising part is at 3.75. So yeah. So t minus 3.75, and our d value is plus 30. There's one equation. Can we what? All right. If I said a is negative, so negative 20 sine 2 pi over 15. Now, it's 30. You're going to the following one, right? Look, you can go to this, and clearly my graph isn't drawn correctly, but that's okay. It's going to be 11.25 for this, the way I sketch this graph. But, and that, you do that, I'll give you full marks. Sorry? It's positive, but remember it's like x minus your c value. So yeah. Remember that this graph is like actually repeating, right? So the actual nearest falling midpoint would be to the left. I'm not going to comment on the first part of that question, but you can give me that one. If you give me the 11.25, that's fine. Okay. Well, that if you just put that in there, you're going to get the same graph, right? And then you just fix the domain.
Yeah, but like technically, if this was starting from less than clockwise, so from 0, that would say at negative 11.25 seconds.
But it gives you the same graph, right? I understand what you're saying, that yes, we're not going to go in the negative direction, but it gives you the same graph, so then you can just restrict the domain after that. Okay?
Okay, so like, yeah, technically that exists, it's just like it doesn't because of the house. Like that would exist if we weren't in a situation of there's time limiting us.
Yeah, yes.
At negative 11.25 seconds.
But you could write that, generate the equation, and still answer all the questions and get them the same. Yeah. So, but 11.25 is fine for me. Okay? Yep.
On a test, will you ask for us to give all 4 equations?
No. So this type of question on a test, I will say just give me an equation. I'll talk about in a bit a multiple choice question where it's not as involved as this. I could limit you to all sine graphs or all cosine graphs. So you should know how to do all of them for one question, but for the big one like this, you can give me any one you want. All right, so there's the 2 sine graphs. Let's do the 2 cosines. If you're doing cosine, what are you looking for? So your nearest, if max or min, right? Yeah. So if a is positive for a cosine value, everything stays the same. Keep writing y. H of t is equal to 20 cos 2 pi over 15. And my max is right there at 7.5. So x t minus 7.5 plus 30. And if you're doing the minimum, so a is less than 0, what's your shift? 0, exactly. So if a is negative, you're looking for the minimum. There's a minimum right at the origin. You haven't shifted. So your c value is 0. All right. Are we okay? Almost. I got one more to do and then we're done. Where did you get this 7.5? I'm looking for the max. When you're doing an A value that's positive, because cosine graph started a max. So I'm just close this max real quick. All right. Are we good? We're gonna do another one. Because the minimum is right at the origin. Right? The minimum y value, so the height, how has that been shifted from the y-axis, like the shift left to right? That's why when a is positive, it's 7.5 because you're looking for the max. When a is negative, it's just the minimum. Yeah. All right. Yeah, I mean, you could have used 15 if you really wanted to, but that's what. Yeah. Okay. All right. Flip the page, please. All right. Physics people, ignore all reality right now, and we're gonna pretend that this works. What? No, this is just a spring and a weight. Okay. These are all taken from old provincial exam questions. It's attached to the ceiling, I believe. I'm assuming this is the ceiling. All right. A mass is supported by a spring so that it rests 50 centimeters above the top of a table. So that is 50 centimeters. The mass is pulled down to a height of 20 centimeters and released at t is equal to 0. It takes 0.8 seconds for the mass to reach maximum height of 80. As it moves up and down, its height is approximated by a sinusoidal function for a short period of time, i.e. we're pretending that gravity and friction don't exist. So like 2 probably rotations, and then it's all messed up. Okay, let's make a little table of values here. Boom, boom. Time, height. So it's height above the table. So we pull it down so that it is 20 centimeters above the table. So when t is 0, what's its height above the table? 20. We release it. It takes 0.8 seconds. I'll highlight this. 0.8 seconds to reach a maximum height of 80. So at 0.8, whoa, I guess I'm not writing in highlighter. 0.8 seconds, it has a maximum height of 80. Assuming no friction and gravity, okay, how long does it take to come back down? 1.6. So one complete rotation is 1.6. What's its height after 1.6 seconds? 20. And then after that, I think everything goes sideways, and this doesn't really apply anymore. Sorry? To go up, and it takes another 0.8 seconds to come down. Yeah. So there you go. There's your round trip. Let's sketch a graph.
It's losing momentum.
Yeah, we're pretending that doesn't exist. So really, this works for like one cycle. Yeah. That's about it. If that. I don't think it would either. It'd be interesting to see how exact it would be. Like if you generated the equation and then you could measure at all the different pots. Sorry?
Does it come down? Does it come back down?
We're pretending that it does. I doubt it would, but we're pretending that it does. All right. Time on the x-axis, height on this axis. At 0 seconds, how high is it? 20. At 0.8 seconds, it's at 80. And at 1.6 seconds, it's at 20 again. It would probably just get, the amplitude would get smaller. Yeah. Okay. Determine an equation, blah, 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 blah. Okay, what do we do? Find all the values. So A is probably the easiest. Oops. 50 is B. Or D, sorry, D value. I got all excited. D value. That makes way more sense. All right, what's the period? I'm just going to leave it as 2 pi over 1.6.
Why did we do that?
0.8? Is that better? Pi over 0.8? We can do 10 pi over 8. No?
Why don't we just put it? Oh yeah, this question.
Okay, 5 pi over 4. Does that make everybody feel better? Okay. How did I get 5 pi over 4? What's 1.6 as a fraction? 1.6 is 16 over 10, correct? Okay, that's the same thing. There's a lot of questions coming at me right now. Okay, first of all, it's over P because that's the formula. Period is equal to 2 pi over B, and then you switch the B and the P. I understand what you're saying, but I'm going to do it this way. Because I don't think it's natural to go 1.6 is just 8 over 5, like that. I think it's natural to go, oh, it's 16 over 10. I know, but I've never been accused of being smart, so. So times 16 over 10, reduce that, you get that. Okay. Did I do that right? Is it? It's not 5 pi over 4.
No, it's definitely not.
It's 32 over 10, which reduces to 16 over 5. Right? Yeah. Hang on. Oh, it's because I wrote 16 over 10. It's 10 over 16. That's why. There. So it's 20 over 16, which then reduces to 5 over 4. Okay. There we go. Are we okay with that? Why are we getting bogged down in this? Oh my god. This one. Okay. I don't even know what we're doing now. What are we doing? C value. Thank you very much. Okay. Sine. If we're doing sine, A is What? A is greater than 0, so A is positive. We're going, what am I even writing now? H of t is equal to 30 sine, what's my b value? Oh, the controversial 5 pi over 4. X, and then the d is plus 50. Okay, if we're doing sine with a value positive, we're looking for rising midpoint. Where's the rising midpoint? Where's that point? It's at halfway between 0 and 0.8. What is it? 0.4. Oh, there we go. What number? 0.4. All right. If we're doing A is less than 0, you're looking for the falling midline, which is way over here. What is that number? 1.2. Does everybody agree with that? All right. T minus 1.2 plus 50. All right. On a graph like this, I would always just do cosine because they're more straightforward to me, but it's up to you. If you're doing cosine, A is greater than 0. What are you looking for? You're looking for the max, right? So it's h of t is equal to 30 cos 5 pi over 4 t minus what? Yeah. T minus, not 80, 0.8 plus 50. If A is less than 0, what is it? There you go. Your C value is 0, right? Because your minimum is right at the origin. I don't care which one you give me. To me, cosine makes a little more sense. How's that? You feel like you can do the rest of the package? I think we should just go for it. My apologies to everybody that's watching this video. Good luck. That was A block, pre-calc 12, Royal Bay Secondary School, room 3143. They can't hear you.